Okay, guys, let me show you another way you can do that last class only problem that we did last class. Yeah. It was the last one. I'm not lying. All right, guys, let's go ahead and push stat on our calculator. Okay, we're doing hypothesis tests, right? So do you think maybe we should look at what's in our tests? I know. We're so smart. Okay, you need to know the name of your test if you're going to actually use this function on your calculator. Okay, so do you remember the one with the chips? What kind was it? It was a Z test. We don't know a lot of these yet, do we? We know Z. Okay, so we're going to pick that one. Okay, from here you have to decide, is my input coming from data? Like, did I put a list of values in? Or do I know the stats on it? Like, do I know mu and x bar and all of that stuff? So what do you think? Do we have a list? Alicia, here you go. Do we have a list or do we know things about the bags of chips? We know stuff, right? Okay, so pick that. All right, so I'm going to arrow over to stats. And push enter. Could I fill in all of these things? Yes. What was the mu for the chips? 120. Did I know sigma? 12. Did I know my x bar? 5. And do I know the sample size? Okay, now you are picking. This one is your two-tailed test. These are your one-tailed tests, this being on the left side or on the right side. Which one do you think we're going to use? Yeah, so this guy, you're going to pick that. Actually highlight it. Okay, now two functions we're going to do here. Let's go ahead and calculate first, just so you can see it. So what this is giving you, it's giving you the z-score. It is giving you the p-value. Okay, isn't that the same p-value we got? And then you can base your conclusion off of that, yeah. Okay, well, let me see where you are. How far back do I need to go? Oh dear, the beginning? Yeah. So if you decide to use this, use your calculator, the test function on your calculator for it, what do you think I'm going to make you do? Yeah, like you have to label a lot of things. So you need to list out for me the stuff we put in. You need to tell me what mu was, what sigma, what x bar, what n. List all of that. You must tell me, this is called your test statistic. I can't say that right now. Your z-score, you need to tell me that, and you have to tell me what the p-value equals. And you have to label it, p-value equals this. Then you can write your conclusion. The other thing that's really helpful for this, go back and kind of do it again. Go stat, test, z-test. But now go down to the bottom, and instead of calculate, I'm going to pick draw. Wow! Should you ever screw up a picture again? Yes. No! No, you will not screw it up, okay? And then you have two choices for labeling it. It tells you what the z-score is. So if you want to label it standardized with this being 0 and going to the left, you could do that. You can still label it with 120 right here and this being 117.5. They're both correct, okay? Does that make sense? Are we off to a better start than we were on Monday? Yes, better? Okay. Questions on that one? Probably have something else being graphed. Only dim.
I give that a solid 6.5 out of 10. Having volume to it.
My mom gave it to me.
Oh, I like your costume. Where is that other costume?
Yeah,
We wanted to know, were they overestimating? And if you're
I don't know. I'm on a dumb design.
exactly what I was saying. This is still like with the chip one, it's just showing you
What are
another
you
way
doing
to
in my
use that
school?
one. Okay, let's see.
I'm just trying to look for my
Oh,
phone.
in your first y equals, you were trying to graph two front sides. Not what you want to do.
What does it say?
All right, we okay? Bryce, were you good on that then?
Yes.
You got there. Okay, you're caught up. All right, let's try a little more then. Okay, we're going to talk about our errors just a little bit here. All right, I'm going to draw a box for you. Hi. Welcome. Hey. Welcome, guys.
Hey, remember the time,
All right, guys, start jotting down this box. My label here is that the null is true. Here, the null is false.
can't be quick all the time. Oh yeah, the red one, yes, definitely.
All right, guys, so we have a true null, a false null, we reject our null, or we fail to reject the null. Okay, label those things, and then we'll decide which of these are okay and which ones are errors. Two types of errors.
No true, no
I
false.
think I have left my unit packet on my desk.
Hey, United!
Oh, I don't know. I didn't see one.
All right.
Should I get a new one?
I don't know if I have extra.
I have no true, no false, reject, yes, reject.
Any extra? I have one saved for David. But that's all I have. So I'm just gonna do it on
Yeah, I can just
notebook paper for now. I can make you another one later. I just don't know
Alright. Yeah.
extras right now. Okay.
It might be at home too.
Okay. Yeah, when you said your desk, I was like at home, and then I realized you meant here on the desk. So. All right, guys. So rejecting the null. If the null is true, do you think it's okay to reject it? No, that's a problem, right? That's called a type 1 error. The null was actually true, but we reject it. What if the null is false and we reject it? That's kind of the goal, right? It's false. We are like saying, hey, that's not true. We're rejecting you. So this one is okay. Okay. What if the null is true and we fail to reject it?
That's
Is that
also
okay? Or yeah, we don't want to reject it if it's true. So this one's okay. Any guesses as what's going to go in that last one? Ah, type 2, okay. Yes, you're so honest. All right, and so type 1 error, how they connect to your hypothesis test, the probability of a type 1, that's equal to your alpha. Remember we talked about the significance level, the 0.05 alpha we're going with. It's the probability that you're going to make that mistake. Okay? Where the null is true, but you reject it. So with type 2, the probability of a type 2, that is beta. You definitely do a lot more with alpha than you do with beta with your hypothesis testing right now, okay? All right, so let's connect this all back to confidence intervals because we know what a confidence interval is. So this isn't more error, this is more your hypothesis test. We know what a 95% confidence interval looks like, right? We're talking about this. That's what we mean if we're 95% confident. We think the truth is somewhere in that shaded part, right? And we're 95% confident we're going to capture the truth. So, when we're doing a hypothesis test, if the hypothesized value is in our confidence interval, so like what I mean by that is in the shaded part, we fail to reject. Okay, it's in the part that where we thought it would be, so okay, it's probably true. Like, we're not going to reject that. But if our hypothesized value is not in our confidence interval, like not in the shaded part, that's when we get a reject the null. So what that's talking about, like, if the mean is really the mean, okay, like if that's true, we would expect it to end up in this shaded part, right? Okay? If it doesn't end up in there, that's not very likely, right? So we think something must be wrong. That's when you reject the null. We're thinking the null's probably not accurate. Like the mean might not be what we suspect the mean to be. So if it was, it's unlikely that we'd end up outside of the shaded. Does that help a little with the rejecting, fail to reject? Okay. All right. Power, just a couple things on power. We don't do a ton with it. Really, the biggest thing you need to know about it is how to increase power. So we can increase it. Yeah, I know, it's a little scary. The ways you can increase it are by increase alpha, increase your sample size, or decrease your sigma. And again, for right now, that's all you need. We're going to talk more about what power truly means, but for right now today, that's the key. Okay? All right. Can you see okay? Sorry.
So it increases alpha, increases n, and decreases.
So the ways we can increase power are by doing these things.
Increasing alpha, increasing the number of respondents, and increasing whatever A is.
Yeah. increase its power. Okay. So I think I'm probably going to say no to that. So guys, question about the quiz. If you look at your calendar, which is wrong to begin with, it says next class is your concept quiz. But how do you guys feel about doing the concept quiz the day the data journals are due again?
Yeah.
All right, beautiful. That's what we'll do. So we'll just practice next time. Okay, that gets us
I like that.
wonderful. All right, so let's continue here. Let's try one. And something that I think is going to help you a little bit, if you look past your examples here, this is kind of a lengthy version of it, and then a short version of, like, hey, here's the steps to go through with your hypothesis test. Okay, you guys see this? This is in your text. So let's look at this next one. We want to test the claim that average gasoline consumption per car in the U.S. is more than 7 liters per day. I don't know who buys gas in liters around here, but that's okay. We're going to use this random sample that we have, which represents daily gasoline usage for one car. Okay? So, do you think this is a means or a proportion problem? Means, okay? Do we know sigma? No. So what kind of test do you think we're doing? Okay. So that's the very first thing I want you to identify. We are doing it's called a one sample. That's the easiest way to do it. T-test for means. Okay. On the AP scoring guides, it always says they identify the hypothesis test by name. So tell me what hypothesis test you're doing. That's kind of like one of those really easy points. Tell me what it is. All right? All right, and then let's define what we're talking about. So what is our mu? What do you think we're looking at? What'd you say? Okay, with words, what is mu? But what is that measure? Okay, so we are looking for the true average of gas consumption per car, right? In the U.S.
Wait, that symbol's alpha, right?
Mu?
No, the average thing that looks like a bomb.
Of?
I swear.
Alpha.
I swear, because I swear that like symbol between average and gas looks like a bomb.
It's a word, so.
Yeah.
A little bit like a bomb. But it's oh dear.
Oh great.
Alright, Beckett, it's of.
Okay.
Okay. We're good. Okay, what else do we need to do, guys? I said it was going to be a better day. I don't know. More entertaining. That's okay. All right, what else do we need to do? What do we always need to do? Check conditions. I'm going to do that off to the side here just to try to...
N equals exactly 30. Does that count?
We know a couple things. First, is it a random sample? Yes, so SRS is stated, right? Okay, now normal, the sample size, is it exactly 30? I haven't even counted. What else can we look at? Yeah, because are we going to have to put these values into our calculator anyway? Yes, so go ahead, key them in, I know, but you can do it. Check the normal problem. Alright guys, calculators, not phones right now, okay? All right, guys, are you looking at your normal probability plot? How's it look? Approximately linear. Okay, a few of you on your test are missing this point because instead of saying approximately linear, you're telling me the normal probability plot is approximately normal. Nope, not what I want to, no, that's not what we look at there. So normal probability plot is approximately linear, okay? So checking for normality, and you can even call it the NPP, normal probability plot, is approximately linear.
Are you sure that's not no party preference?
Not today.
All right.
That's what it means to you, then write out normal probability plot. Okay.
All right. Fair enough.
All right. So, we okay so far, guys? Step by step, we're good? Okay. We need to write our null and our alternative. Oh, and guys, what could we have done even without looking at the normal probability plot?
Whoops.
You had to put the data in.
Well, looks like we're using a Z plot. No, looks like we're using a T plot.
All right, so guys, we could have just said the population is normally distributed. That would also work. Okay, both are fine. All right, let's write our null and our alternative. So your null, what do we think that is? This is where everybody gets tired last class. All right, we're talking means, right? Okay, so what's the parameter for means? Mu. What are they saying that the average is? 7. Yes, Alex, 7. Okay. What are we testing here? What do we think it might be?
More than 7.
More than 7. So mu is greater than 7.
Well, this is easy.
Okay. What's our alpha level that we're talking about? 0.05, right? Okay. Again, I don't care which way you do this with your calculator. If you want to go through the formula for the t statistic, like the t-score instead of the z-score, you can certainly do that. Remember, you get a formula sheet and it's on there. Okay? Or you can go through and what do you think you might use on your calculator? T-test. Yeah, that's fine. The things I need from it. I need, what does t equal? I need your p-value. I need a sketch. All right. You also want to tell me x bar, mu, s, n. Okay? And then over here we can make our conclusion. So those are the things I want you to fill in. Let's see how we do. And remember, you put the data into your calculator, right? Okay? So you're not going to use stats this time, you're going to use data. Show you both. If anyone is stuck with their calculator, please ask. I will try to get you.
So data is something that is certain or
It just means data if you actually have No, it's not simple, but like I want to see. So it's
Wait, so would it be greater than?
What if we knew that you're just putting a 7, it's just that's what they're saying?
Excellent.
Like, no, for the values on the Oh, and if once you want to first half, it's the same thing.
Yeah,
Yeah, and then you put your friend in
before where it was like, here's the yeah, it's like, I know all of
Even fries are
but that's not really
How come they always say we live in a society where we never use it?
And we're testing like how likely is it that this probability of getting this X bar if
Try to just go to the folks and say, I'm going
The
yeah?
fact that it fills it in so
I know, it's like,
Yeah.
wait.
It's like perfect.
Alright, anybody calculator issues? How are we doing in the back corner there, guys? Good? Yeah? Okay.
Wait, how many people got stars in the test?
Oh, a lot. I owe you guys stars. I put them in CIS, but I failed to put up stars. That's usually not the order I go in.
Did you get this one?
Did I do better than, you have grade bill.
They're in CIS. I think you got a star. So good job. Hey. Wow, I'm doing. You're on an upswing. I like it.
This is odd. I like barely passed first test and decently in my two, but now I'm like rocking the next two.
No, that's how it's like. That means you're figuring it out. All right, guys. Do you have these values? Yes. What'd you get for your test statistic? What'd you get for your T? I'll just do 1.53. What about your p-value?
0.068.
Okay. My picture, what's it going to look like? And again, I don't care how you label it, but pick one way. If you're standardizing it, this is 1.53, and this was 0. And if you're not, then this was 7, and thank you. Okay, and you're shading. Does that make sense? Like you have to pick one of those ways to draw it? Might be easiest to just go with the T, the standardized way, because your calculator's going to show you that. Isn't that our X bar? 8.2, okay. Then, never mind. Better. Are we okay with understanding the labeling though? Pick one of those ways. Whichever one seems easier to you, you can do that. Jackie, you look like you have a question.
I'm just getting the wrong numbers.
Okay. Let me write these and I'll come look at what happened on your calculator, okay? What did you guys get for X bar? I actually don't have those numbers. 8.2. Mu we know was, okay, what about S? Sure. All right, N? Okay. Yes? Okay, let's pause for a second. Let's see what happens.
Go green.
Wait, if we're using a Z test, then
I wish I had called it.
oh,
Call me Shrek. Call me Shrek. Oh yeah, no. When I wore the dinosaur costume, I was going to visit that day, and I crawled out of it, and I was like, thank you for the representative. Yeah, rights for green people and dinosaurs. I should get a phone for that.
Okay. Yes. Yes.
display, sorry.
You're fine.
So we're doing number 5.
No, we haven't actually written our conclusion yet. Okay, everybody's okay with the p-value, everything that's happening. Remember, the p-value is telling you the likelihood of this occurring, this X bar occurring, if the true mean is actually 7. Okay? So there's like around a 7% chance of this happening. Not super likely, but is it likely enough compared to our alpha level? Yes. Okay, so what we're going to say is, since 0.07 or 0.068, whatever you wanted to use, is greater than alpha of 0.05, we fail to reject our null hypothesis. Okay? There is not enough evidence to suggest that the true mean gas consumption per car, and you could say in the US, is more than 7 liters. These are wordy because the whole defining the mu takes a lot of words, and then you get to use those words in your conclusion. Does this make sense to you what you're writing?
And it is not optimalized.
Whoa. Questions on that one? All right, let's look at number 5. What do you notice right away in this one?
It's proportions.
It is a proportion.
So now,
Okay, so, oh, go ahead.
sorry. So you have to use a z-test, and it has to be a data test since we're gotten, unless you want to type 225 instances of 0.69, you would, well, you'd have to use this, but the standard deviation is 0, right? Or how can we know the standard deviation?
It's proportion, not a means problem, so we can't just use the same
Yes,
z-test.
but
So, guys, we'll get to what you're doing on your calculator. First thing I want you to do is name the test, okay?
it has to be the
We're going to
z-test,
define,
right?
we're going to define what P is, right, since it's a proportion, all right? Then we're going to write our null, write our alternative, check conditions, all of that stuff's the same, and then I'm going to show you how you do it on your calculator. So, the name of this, what do you think? What do you want to call it? It's a proportion test, but for Z, so the way we title it is a 1 proportion Z test, okay? Yes. Every single free response rubric, part of it is named the test by formula or title, which formula is a little weird to write out. I would just name it. Easy points, okay? All right, so what I want you guys to do, try to define P. We'll squeeze conditions in over here. Write your null. Write your alternative. I'm going to give you a few minutes to try this, okay? And then I'm going to show you what can help you on your calculator.
Oh yeah, I had the wrong z-test. Z-test.
I think it'd be right here.
Hey. Yes. What do we have for our P? Like defining the parameter. What do you guys want to say?
0.65?
No, with words. What are we talking about?
The mean of
The true,
true mean of cell phone calls.
not true mean. True proportion of teenage cell phone users that does not say so. Exceeding.
Whenever I try to punch this in the calculator, I get a demand error.
I know, I said I'd show you. So hold on. Okay? Patience. We must learn patience. All right, anybody questions on the P? Okay. Conditions. What are we going to check for conditions here?
SRS stated.
Okay, SRS is stated. All right, proportions. What do we check?
P is
So N times P is what? 225 times
9.
0.65. And guys, give me an actual number. This is something that a few people lost points on the test. You're writing N times P greater than or equal to 10, N times 1 minus P greater than or equal to 10. But you're not actually using any numbers. That's not okay. You've got to put the numbers in there, okay? I don't know what that is with the number. I don't have it written down. Someone help me with your calculator. What?
146.25.
So we'll say 146 people. Definitely greater than or equal to 10. You can just go straight to the 146. Okay. 225 times what? 0.35. I should be able to subtract, but what do I get? Thanks. So we'll say 78 or 79. Definitely greater than or equal to 10, right? Does that make sense there? You've got to plug the values in. You can't just say N and P. All right? Okay. So our conditions are met. Let's write our null and our alternative. What do you think the null is?
0.65.
What?
U equals 0.65.
Okay, are we talking means?
P.
P, yes. So P equals 0.65. Now what are we going to say is our alternative? Greater than 0.65, right? If we're talking about exceeding it, we think the proportion is bigger than that. Because we had 0.69, okay? So P is greater than 0.65. All right. So a few things we can write down right away. We know our P hat, right? What was that? .69. Do we know our sample size? 225. Okay, so a couple things you can do on this. You can by hand calculate the z, the test statistic here. Your formula for that, P hat minus P over square root of P times, maybe I can write 1 minus P. Over N. Okay, you can certainly do that by hand and calculate it. If you want to do it in your calculator, that's fine. Let's go back to what that looks like and what you'd pick. Okay, so of our test, what test do you think we're going to pick? Number 5. One proportion z-test. Make sense? We're doing proportions now, so we got to pick a proportion one. All right, so I'm going to pick number 5. This is where it's just a little trickier with the information we were given in this problem. So the first part, that's easy. What am I going to put into the first line here? 0.65. Okay. What is happening on the next part? Yeah, it's x. It doesn't say p hat, does it? Okay, it says x. So that's talking about how many out of 225.
Ah, that's why I put fractions there. Got me.
Right, it won't work, yes. So you need to figure out what 69% of 225 is. Okay. And I don't remember, what is it, like 155?
155.
Okay. So let's do 155. And our sample size was what, 225? Okay. Now, which one of these am I picking? Yep, the greater than symbol. Okay, so it's like successes out of the total is really what X is talking about. And they told us 69%. They didn't give us the value there. Some problems will actually give you, 10 out of 22 did this. And that's very easy. When it's a percentage, you have to figure out what that X is. Okay? All right. Up to you if you calculate or draw first. I'm going to just calculate. Are we okay with this? Do you see on mine? Oh, that's giving me the wrong. I didn't draw this. You can certainly draw the picture, and then it's going to give you from a z-score of 1.2 to infinity. That's what's going to be shaded. Write some more things. So our z-score, it was about what, 1.22, somewhere in there. Now, it's slightly off because we had to use x being 155 instead of...
You can't have a quarter of a human, so.
Right. It's a little trickier there. The other pieces we need is, we need the p-value. And what was that, around 0.11? Is that what it was? I can't remember. 0.11? Okay. Okay. I should have listed my alpha over here. I forgot my alpha level was 0.05. I need a picture. I'm going to draw this one standardized, so 0 there, 1.22, shade to the right. So guys, I don't need a lot with the picture, but I do need the picture, and I need it shaded. Okay, what do you think our conclusion is going to be?
Since p is greater than alpha, we fail to reject our null hypothesis.
Anybody want to continue?
There is insufficient evidence to suggest the true proportion of teenagers who exceed their monthly minutes is not 0.65.
Is more than 0.65.
More than 0.65.
If we had said not 0.65, that would have been a two-tailed test. We would have used the little not equal to. Okay.
All right.
Good. So let's see if I can squeeze it in here. So since our p-value of 0.11 is greater than alpha of 0.05, we fail to reject our null. Really need to give you more room on these problems, don't I? There is not enough evidence to suggest that the true proportion teenagers exceed their cell phone minutes is greater than 0.65. Okay. Whew.
Did you say 65%?
You could say 65%, absolutely. Yep. Okay. Whew. How's your pain?
That'll be a good place to break for lunch.
Sure. Okay. Maybe.
Yeah.
Yeah. See, we're great.
This is
Totally.
good stuff. Good stuff.
Might be. Okay, so tests.
Yeah.
We're gonna pick the one proportion Z.
I can't focus.
Okay. Do you get why we picked that? Okay. All right. That's what they're saying is the true proportion is 65%. Do you know where I'm getting the 155? Okay. So they told us in our sample 69% exceeded. So that's 69% of 225. Okay, you just have to put it in as like successes over total is basically what you're doing. Yeah, that's the one part that's weird. Okay. And then I'll draw this time.
It reminds me of this down and then
I know it's a little weird. It's like, ooh. Yeah, it's very strange.
and it's like satisfying. It's every single color.
But guys, this is great. It gives you your Z, it gives you your p-value. Like, this is a very good reminder of like, oh, I need to tell you all of these things. Okay, I need a picture. I need these values. And it's out. Okay, guys. Let's see. Start looking at 6. It's our last example. We're not going to go through it before lunch, but start looking at it, see if you can at least identify what tests you're doing, what your parameter is. Let me take attendance. Oh dear.
No, it is covered.